specifically a linear and a quadratic. The first step, if we're solving graphically, which is all we're going to be doing in this section, with quadratic and linear combinations, is we want to solve our equations for y. So we want to isolate our y and bring it down. Everything else needs to move across. So we do that by adding the opposite operation of 2x, which is negative 2x. And since 3 and 2x do not have x on both of them, we can't add them together. They have to stay separate. So we just rewrite the equation so that we have our variable first. The same thing is going to happen on this side. We're going to move this minus 6. And notice I put it behind everything because you cannot add 2 times something to minus 6. So we're going to bring down our y. 6, sorry, our y, not our 6. 6 will go away. And then we have x, 2 times x plus 1 squared minus 6. Okay, so for graphing, we're going to follow these steps. We're going to go to step 1, which is go to home, pick new, pick graph. We're going to type in our first equation, hit enter, and it will draw our graph. Then push the tab button, which is highlighted on the picture. Type in the second equation. Now you may, and that's actually below this, sorry. Type in your second equation. You may need to change your settings. This is wrong settings. It should say negative 15, not, or positive 15 as the highest point. And then we are going to push menu 6-4 to find the intersection. We will put our dotted line somewhere in front of the two graphs, hit enter, pull across until our point shows up. If you don't immediately see the point when you've actually set your settings, you may have to reset them, which is what I had to do. And then we put our dot in the middle, do menu 6-4 again, start with our dotted line in the middle, pull across, and when we see our second point, hit enter. So our answers is the entire point. So the entire thing, everything that we have gotten on our graph for both points is our answers. So we need to write our answers in point form, negative 3.9 comma 10.8 and 0.898 comma 1.2. So the entire point is part of the answer, not just the x in this case. Because what happens is we're looking for where the graphs cross, the actual position where they cross. Okay, so we can also graph algebraically, but we only don't want to do that when we have linear equations. And I designate the linear equations 1 and 2, these just reference points, so that you can see I'm using equation 2, I'm using equation 1. And again, we have a couple of ways we can do that. We can use substitution. Substitution means that we're going to solve one of our equations for one of the variables and then use that to substitute into the second equation. So I'm going to try to get y by itself because it's obviously already just y. And to do that, I'm going to move the 4x just like I did on the previous example. Bringing down my y equals negative 4x minus 3. Now that I have that, I'm going to take that negative 4x minus 3 and I'm going to replace it into everywhere I see y in the second equation. So I'm going to do 2x minus 4 times negative 4x minus 3. And this gets rid of my y value, but it still is identified by the negative 4x minus 3. So now we use distributing or double rainbow. And negative 4 times negative 4 is positive 16x. Negative 4 times negative 3 is positive 12. And that gives us that. Now we want to combine things that are the same and move things that are different. So that keeps all of our x's on this side, and that becomes 18x equals, and then our 12 moved on the other side, which makes it negative 12, or negative 6. So we got 18x over here equals negative 6, and then we can divide by 18. So x is negative 6 over 18, or negative 1/3. Okay? So now we're going to take what we just found with our x, the negative 1/3, and we're going to replace it into the first equation. So we're going to take this and stick it in where x is here. plus y is negative 3. Now I like to get rid of my fractions, but in this case I think I'm just going to move it on the other side. So when we want to move that fraction, we want to again get y by itself. So the opposite of negative 4/3 is positive 4/3. That will go away. So our y is equal to negative 3 can be rewritten as 9/3. So negative 9/3 plus 4/3, and that gives us y as negative 5/3. So our final answer here is negative 1/3, comma, negative 5/3. Okay, a second way is called, you can use your graphing calculator to check the answer, and you may need to change your decimals into, or your fractions into decimals, because your calculator will give you a decimal form. Menu T1 on your calculator will allow you to type in the fraction, hit menu T1, enter, and it will tell you that negative 1/3 is negative 0.333 repeated, and negative 5/3 is negative 1.6666 repeated. So if you don't recognize the decimal on your calculator on the graph, you can always put your fractions into the menu T1 and it will change it to decimals, and then you can compare them. So our next step is we can also use elimination. The goal is to either eliminate the x or the y by adding the two equations together, resulting in that variable going away because it adds to 0. So if you're not sure what a common factor is that you can add to 0 between like 6 and 12, because I'm trying to get rid of y, you can use menu 2-4 on your calculator, which is another calculator function that gives you the least common multiple. So you put in 6 and 12, hit enter, and it will say, well, they both have 12 in common. They have the answer 12 in common. So the idea is that we want to change one of the equations, the first equation, so that we end up with negative 12 at y instead of positive 6y. So the way we do that is we're going to multiply both sides by what times 6 equals negative 12, which in this case is negative 2. And we want to do it to both sides because anything you do to one side, you have to do the other. We're going to multiply those. So negative 2 times 3 is negative 6x. Negative 2 times 6y is negative 12y. And negative 12 times negative 2 is positive 24. Now that we have that, we can move that down and put it with our second equation, our new first equation, which is still the same line. It's just been multiplied by 2. Now we add straight down. So we're going to say negative 6x plus 5y is negative x. Negative 12y plus 12y is 0. And 24 plus negative 18 is positive 6. So we want to get x by itself. So we're going to divide by negative 1, because remember there's a negative 1 in front of x. We'll divide by negative 1 over here. That gives us x is negative 6. Now we want to put in our negative 6 into our original equation. So we're going to take our negative 6 and put it wherever we have an x. So 3 times negative 6 plus 6y. And it's really important you go back to the original equations that they originally gave you, not anything you've already manipulated. Because if you made a mistake, then you'll be messing up your math. But if you always use the original equations that were given to you, if there's a mistake, it won't be because you've rearranged it wrong. So negative 18 plus 6y is negative 12. So now we're going to solve for y. So I put y into a box, add 18 across. 6y is equal to 6, divide by 6, and y is equal to 1. So our final answer is negative 6 for x, positive 1 for y. Okay, so you have been given a worksheet, and now you can look at your answers. So for number 1, we used substitution, because you could simplify the bottom equation. So it would be y equals negative 8x minus 15. Do substitution, and you end up with negative 1, negative 7. So on problem number 2, we're going to use elimination. So the best thing to do would be to try to add 20y to its opposite, negative 20y. So we'll multiply everything by negative 2, which will change the second equation to positive 10x minus 20y equals positive 20. When we add down, we find that both of our x and y's actually are eliminated, making 0 on that side. But on the other side, we have negative 26 plus 20, which gives negative 6, which means that if 0 is not equal to negative 6, which means there's no solution. On number 3, we are going to use, again, elimination. So we're going to try to get rid of the 12 this time, 12y. When we do that, we again actually end up eliminating both the x and y, making 0. But on the other side, we add up to also 0, which means that there's all solutions. And on the last one, we used, again, substitution. So we sub for y, making 2x plus 11. We plugged that in, and then when we ran through all of the calculations, we ended up with a point of negative 7, negative 3. Now, again, you can put in both of our equations after you've rewritten them to equal to y into our calculator, and you would find where the intersection was. So using the graph and calculator, I also have done the problems 5 and 6. You can see what the graph should look like on your calculator. On number 5, we have the 2 points of negative 1, 3 and 2, negative 6. And then on number 6, they do not cross, so that's a no solutions. That's what a no solutions would look like. And then finally, we have a word problem. So the most important parts of the word problem here are the 2 equations and at what point can they grab, which basically means where do they intersect. The rest of that was just a story. So if we actually graph this, we can do it one of 2 ways. I've shown you how you could write out your table and plot your points for both your first equation and your second equation by plugging in your x value into our x's in the equation and solving for y, and then plotting your points. And then you can see where they're connected, or with a calculator, you would put in the 2 equations and find out where the intersection was. So the most important thing is to make sure you're answering the question. The question said, at what point can the trapezoidus grab the second acrobat? So you would want to answer your question in a full sentence. The trapeze acrobat will catch his partner at coordinates 4 to 20. So 4 feet up, 20 feet to the left, or something like that. Okay?